And this is the quick review to graphing quadratic inequalities. And so remember, we're expecting a parabola. And we're going to remember that we want the coordinates of the vertex. And so we want this standard form. Y equals a times the quantity x minus h, quantity squared, plus k. Because our vertex are the values of hk. And the a, whether positive will be a min, negative will be a max. Okay, this one's close. We got to move this -2. So we'll divide the left by -2, and we'll divide each term on the right by -2. All right, so, and remember, whenever multiplying or dividing an inequality by a negative sign, you always reverse, flip, switch the inequality symbol. Okay, so we end up with y. A 4 divided by a -2 is a -2. We still have x plus 2, quantity squared, and now we have positive 5. All right, because of this negative, I know it's a max. Whoops, come back. All right, we'll just leave that. We know it's a max. All right, the h value is a -2. Notice that the h is in red and the negative is in black. So in order to get a positive 2, it must have been negative a -2. All right, so our x-coordinate is -2 of the vertex, and our y-coordinate is 5. Okay, so you always want to plot the vertex first, so I'm going to go to -2, 5, plot my vertex. My line of symmetry will be right here. I know this is a max. Okay, XY chart will allow me to finish the look of the parabola. Now, here's an important thing. I'm already at an x value of -2. All right, so I want to move 1 over and use -1. All right, so I'm going to use -1 for my XY chart. So when I stick a -1 in, so right here this is a -1, -1 plus 2 is a 1, 1 squared is 1. 1 times -2 is -2, -2 plus 5 is a 3. So you get the point 1, 3. So 1, 3 is right there. And because of my line of symmetry, I have the point -3, 3 right there. Let's do another one. So I go to 0. Again, put in 0 for x. That leaves 2. 2 squared is 4. 4 times -2 is -8. -8 and 5 is a -3. And so now I have the point 0, -3 right there. And using my line of symmetry right there. Okay, now don't forget to draw the graph because it's a greater than but not greater than or equal to. Remember, the equal to part is the function itself, the parabola. Because the equal to part is not part of the solution, we have to use a dotted line. So this line should be dotted, meaning any point on the parabola does not make the inequality true, because that would be the equal to part. It would be like saying 5 equals, or like saying 5 is greater than 5. Well, 5's not greater than 5, so it's not true. 7's not greater than 7. So we dot the line to say those are not part of it. Now, looking at the symbol, we could use a test point to shade the proper side, or we can understand where are the greater than values above, where are the less than values below. Well, this is a greater than, so we have to shade above, and in this case, above happens to be outside the parabola. And you can do a test point. You'll see that any point in the green shaded area makes the inequality true. Any point inside the parabola makes the inequality false. Hey, we just graphed the quadratic inequality. So remember a couple things. With a quadratic inequality, you're either going to use a solid line if it's equal to, and a dotted line if it's a less than or greater than. And remember, you always have to shade the solution set above or below, and it could be inside or out, depends upon the parabola, whether it's a max or min. All right, that's it. There you go.